exiting one of our classes to join us. They were eagerly awaiting, and so they are with us. So I welcome all of the students, all of the faculty, any guests that we have. Thank you guys for coming to this. This is our premiere launch of our Distinguished Lecturer Series for the department, and we're really excited to have Mr. Assaf with us. He has been called the database guru and has written the book on the subject, and literally he's written the book on the subject. So I want to just introduce him if I can. He is a principal consultant at Sparkhound, and he's the author of 2 books. Like I said, he wrote the book on the subject. He's the author of 2 books for Microsoft on the SQL Server database platform and database design and development consultant for the past 15 years. So he's also been a part of writing and designing the certification exam, the cert for Microsoft, since 2012. And this year he was named as Microsoft Data Platform MVP. So one around in 350 honorees in the world. That's a pretty elite company. So it's really an honor that he's taking some time out to speak to us. Before COVID, he was the organizer of the annual Baton Rouge SQL Saturday conference, and now it's a virtual, of course, SQL conference, and the server community in that area. So he lives and works in Baton Rouge. He's joining us virtually from his home, and he has some really important and great information to share with us. After he gives us his lecture, we're going to have a Q&A, and I'll try to help facilitate that since we've got people live and people in the chat. So let those wheels turn, just absorb and learn everything he has to offer us. So without further ado, Mr. Assaf, it's you.
Great. Thank you, Bonnie. Looks like my screen is loading up now. Gonna get a thumbs up if y'all can see that. Awesome. So it's a pleasure to speak to all of you again. I've spoken to audiences of Southeastern University students for a few years and in a variety of capacities. And at the end, I'll explain why I do all this. But for now, know that I am honored to be here and I'm enthusiastic about what I do. So first though, let me get started with a little story. A little story I like to call, I was once a very lousy carpenter. So did I do side projects? Was I interested in my work outside of my work? Did I study for certification exams? Did I go to user groups or participate in the tech community where I was? Nah. Minimum effort? Yeah. So I did what I was told. I didn't try to expand my skill set. Those video games weren't going to play themselves, right? I was just doing the job. And I made goofs all the time because it's just a job. It wasn't very good. I wanted to be a better carpenter. I really did, but I couldn't find time to make myself into one. That was my employer's responsibility, right? So sometimes what we want to be and what we do every day aren't the same thing. Problem is that I got tons of these pictures. The internet is full of them, but I think I'm done now. So started studying in my own time. I showed interest. I paid more attention. I stopped pointing out roadblocks and I started developing solutions. I started attending local user group events and participating in the tech community. I created my own related side projects, even if no one ever saw them. And then my work started improving. Turns out what I was developing were better habits around improving. I started intentionally learning again. Did I make mistakes? Sure, but I was on the path. You are not going to be a very good carpenter if your own house isn't full of your own projects. The only way to learn is to do. Don't expect to learn everything from your school or employer. Now, by all means, go and get the degree and make every note of every project that you complete for Alkadi, because every project belongs on your resume. Now, confession. I have never actually been a carpenter. This whole thing was a metaphor. I did do a Habitat for Humanity build, and that was pretty fun. But carpentry is a much nobler profession than the havoc I see wreaked in my databases by developers. But better habits, including my own priorities and my own personal time, make us better. So, in summary, new habits are like going bald. I knew I needed to, finally decided to. It was a shock initially, not just to me, but everyone. Not everyone liked it, but they got over it. Soon, I couldn't imagine ever liking having hair. I encourage you to follow up on your desired habits. And to quote my wife, who is much wiser than I in things like this, those who do the things, do the things. Now, let's get started with today's talk on databases. I was asked to talk to you about what I do, which is to develop solutions in the Microsoft Data Platform specifically, but in databases and data structures generally. So I'll save time for some questions at the end. First, I want to start by saying, what is not a database? Flat files, like comma-separated values, even JSON or XML. These are not databases, including columnar data files like Hadoop Parquet. Azure Table Storage, or any kind of similar product that allows you to just write rows to a table in a cloud somewhere. Microsoft Access databases, not databases. And then Excel and other spreadsheets, the most popular BI tools in the world, but not databases. There are dangers of siloing data in Access, in Excel, in spreadsheets in general, in Power BI or Tableau, or any data visualization tool. And by siloing, I mean it becomes owned by whatever department or whatever analyst happened to be creating it at that time, not part of the general IT structure. Though these are valuable tools for self-service business intelligence, these Microsoft Office tools are not databases. That's not where the data should live. They're fine for data analysis. In fact, none of these options should be where the primary data store of data is, the gold standard or the gold record of any kind of data, because none of these technologies have been designed with some key database features in mind. Let me talk about those features. Features you take for granted. Disaster recovery. For example, you take for granted the ability to back up and restore files. But to accomplish this, you often need to involve other tools or platforms. Given adequate levels of activity, we'll need to be able to do backups and restores to a database incrementally to achieve point-in-time restores, leveraging a chain of transactions, as opposed to haphazardly taken copies of the whole file. A mature database platform does this out of the box. High availability. We're talking about the ability for the source to be resilient to server or site or a student's laptop's failure, to actively replicate from one site to another, or potentially to leverage that secondary replica for read-only queries for analysis and reporting. A mature database platform does this out of the box. Transaction support. Imagine you want to insert 3 rows, but something goes wrong midway through. As a developer, what scenario would you rather have? 1.5 records inserted in an incomplete state, or 0 records? Now imagine it's not 3 rows, but 3 million rows. Any mature database platform has transaction support, and even lots of new non-relational database platforms that we're going to talk about today aggressively market themselves as having full application support, because developers know transactions are important. Nobody wants a database state to be left in an incomplete state that can't be fully committed or rolled back. Proper transactions allow you to do all or nothing writes that commit fully or roll back fully. And finally, concurrency. As important as those 3 first things sound, this is the most important one that developers take for granted. Just like a lot of student projects fall apart as soon as Al-Qadi looks at them, a lot of oversimple, immature data storage layers fall apart when 2 users try to, say, insert data at the same time. I promise you, it isn't a small thing to handle on your own. Don't recreate this wheel. Databases have sophisticated internal consistency and isolation layers. We'll talk about those that are scalable for up to millions of concurrent users. The only way you'll be able to handle a website that, say, handles betting during the UEFA World Cup or trading in a stock market. So I want to talk about this because it's a popular Office application. It's used in schools a lot, and it's great for rapid application development. But my first exposure as a student to databases was with Microsoft Office Access 97. And even then, my underpaid, underappreciated state university instructors assured us that Access wasn't a real database. It was more like a database simulator. I didn't really understand it then. I thought, hey, I've got tables. I can write select statements. I can select data types. This has got to be the pinnacle of database technology. It wasn't until I entered consulting and had some exposure to nightmare IT scenarios surrounding Access. Problems with corrupted data, Access databases on somebody's desktop that were lost due to a spilled cup of coffee, issues with integrations in other data, issues with growth as they had more and more people trying to use the database at the same time. Access is great for students, but thanks to your modern, underpaid, underappreciated state university faculty, I know your projects are already on modern, real, grown-up database platforms like Microsoft SQL Server or even MySQL. So you've bypassed this phase in your career where it occurs to you, hey, putting my entire enterprise's operational systems, including time entry, accounts payable and receivable, and payroll in Microsoft Access, essentially a student-level database simulator, is actually a bad idea. But why is it a bad idea? You only need to read Microsoft's documentation. The 32-bit, that's right, 32, it'll never be 64. Jet engine can only handle a limited number of sessions. How limited? Multiple. So 2. It's not intended for high-stress performance. That's jargon for will not scale. If you've ever been given feedback that your code works, but it will not scale, that's at Microsoft Access. And Access is great for rapid application development, or RAD, for small or single-person teams, for data entry forms and integrated reports. But as soon as people's jobs and payroll start depending on this data, it's time to get that data into a real platform. And by the way, all of these same arguments apply to Microsoft Excel, to Google Sheets, both of which have become highly programmatic and core to many large business functions that I've seen. Spreadsheets are not databases. Spreadsheets are not an enterprise data store. They're an analysis and presentation tool. That's not where the data should live. So what is a database? Really, it's the only thing you should consider for using to store important data, enterprise data, even video game data, market data, social data, where the integrity and consistency of data is paramount. That doesn't mean you can't scale up. That doesn't mean you can't have high performance. We'll talk about those arguments. All databases follow some implementation of a universally accepted ANSI standard for querying language, where the basic fundamentals of the language are the same throughout. Learn SQL, and you've learned the basics of a lot of different enterprise database platforms. The basics of SQL, and by the way, it's pronounced SQL, not SQL. The basics of SQL are universal, but many important vendor-specific features are non-standard and not interchangeable, and they require cross-training from platform to platform, Microsoft to Oracle to IBM. So for example, even the creation of tables and indexes or the taking of backups is going to be drastically different from platform to platform, even if the underlying language, select star from table, remains more or less adherent to a standard. So let's talk about ACID compliant databases. So more specifically, and perhaps more academically, let me define to you what actually defines a database, what makes up a database. And the industry term, ACID compliant databases. Why is it called ACID, not CADE or CADI or CIDA or DAISY? I don't know, probably because all of this was invented in the 70s. First, atomic. We talked about this earlier as something that developers take for granted. A transaction is committed or rolled back entirely. The database can't be left in a partially committed state by any sort of failure, software or hardware. Consistent. This is a big one. Transactions bring the entire database from one state to another, not just a single part of the database, not just the part of the database that the user was accessing. This affects both how users interact with the database, but also how partitions or shards of the database behave together. While many databases have a single primary node or monolithic approach, there are architectures that allow for multi-primary database nodes that can accept transactions globally and then merge their changes together. That inevitably involves something like eventual consistency, a breaking of this ACID compliant chain. Eventually consistent databases can't claim to be ACID compliant. That could be useful. There are NoSQL platforms like Cassandra and MongoDB and Redis, or the database platform that Twitter wrote for itself called Manhattan. Twitter cannot commit a transaction globally, consistently, synchronously. It's eventually consistent. So your hot take tweet takes some time to globally propagate throughout a distributed system. So next is isolation. Isolation and various isolation levels are crucial to understanding database access and the basics of how rows become locked in the various types of locks. It means transactions line up and potentially block each other so that they can do their thing to the database sequentially, independently. By default, most ACID compliant databases operate with a pessimistic locking strategy, assuming that we need to protect multiple requests from each other. Reads lock writes while they're reading, and writes lock reads while they're writing. This is a very basic functionality around the concept of committed data, and only wanting to read data that has been committed to the database as opposed to data that has yet to be committed. Incomplete transactions should not be visible to other users. We're going to talk about that a little bit more. And finally, durability, which seems pretty obvious. If you turn the power off, the data's got to still be there. But this was very crucial back then when non-volatile storage wasn't cheap, but volatile storage was even more expensive. This is still the case today, by the way, that volatile memory is much more expensive and faster. Even if your non-volatile memory, your hard disk, isn't on spinning disks, but on flash or SSD storage, the availability of volatile memory is still crucial to the performance of a database. Databases could all run much, much faster if we all promised to never turn them off. But eventually data must be hardened to non-volatile memory, and that takes time. It's the single most time-expensive thing in a database. That hardening to non-volatile memory is what makes your data survivable. All of these aspects of ACID may be violated in the name of performance. Most database platforms honor them by default, but have advanced features that allow a developer to violate any one of these, especially the consistency and durability parts. As long as the devs are aware of what they're doing, it's probably okay. But again, that JSON file you're using for your entire data layer doesn't promise you any of these. So we won't spend a ton of time here, but the key here between pessimistic and optimistic is really about updates. Inserts and deletes, how they interact with selects are easy enough, but updates, that's the tricky part. Pessimistic transactions would rather your update wait for exclusive access to the data than try to update data that's already changed out from underneath it or is in the process of changing. If you can't guarantee your update will be isolated, just wait. It assumes more than one cook in the kitchen, and that's safer. Optimistic transactions assume nobody else will be trying to change the ingredients, but if they do, somebody's going to get burnt, and that's okay because they'll have to try again, And that's as far as my tortured metaphor takes it. But optimistic transactions require the application, perhaps independently of the database, to quickly solve transaction conflicts, resolve merged data, pick winners, and cause losing transactions to fail. The failure rates should be much higher. Optimistic transactions fail when you go to delete or update rows and they're not there anymore. Or you go to read or update rows and the rows or the row counts have changed. It can become a real tangle, and the database and application need to be more sophisticated about transaction management, tie breaking, and especially retry logic. If you're not sure what to decide, review your system's business requirements. A stock market where everyone must access the same price at the same time, and the price changes a lot, pessimistic concurrency is needed, or the market won't be fair or trusted. Creating the next global social media app. Optimistic concurrency allows for globally distributed data that inserts well and scales and reads infinitely. But boy, are updates a pain. And who cares if my tweet doesn't show up in Egypt right away? Something in between? I'd recommend starting with safety and violating ACID principles only on demand, but not by design. So, relational databases, or as you might see, RDBMS, Relational Database Management Systems. NASDAQ runs on a SQL Server, a relational database engine. The database behind bwin, which we don't really hear a lot about in the United States, but it's the largest gambling website in Europe, runs on Microsoft SQL Server. Stack Overflow, the website where much of your homework comes from. Dell.com, the Fox Sports mobile app, all run on Microsoft SQL Server. These workloads need to process perhaps millions of transactions per second, while also processing them with integrity, with reliability, and without high rates of transaction failures. Key enforcement, like primary keys, foreign keys, between tables and the uniqueness within tables are very important. Relational database solutions were generally designed for single server architectures, monolithic architectures. But this is not the rule. Sharded or partitioned architectures are possible. They're just not easy or simple. And finally, relational database systems allow for analytical style queries, reporting essentially, that joins data across many tables. This gets tricky if you're not enforcing data integrity across common keys, for example. So that would be the case of NoSQL databases. So NoSQL databases are a category of database platforms, not a specific product, but they're designed intentionally and specifically around different data structures or to specifically break ACID compliant rules. NoSQL databases are more defined by how they store the data than anything. Although many early NoSQL databases were open source, that's not a defining feature. There are many open source relational databases like MySQL or MariaDB. And there are many proprietary NoSQL databases that are commercially available as well, all from the major technology vendors like Microsoft, Oracle, AWS. Non-relational data is less concerned about foreign key management, uniqueness enforcement, or the ability to even join data together, and more about the speed, the scale of data retrieval and data writes, and the architecture behind the data. NoSQL databases may store the data in documents, maybe even JSON snippets, or they may store in key value pairs or in graph nodes, each specifically designed for that model of data. As a result, analytical style queries across large swaths of this data is difficult. Many will argue that NoSQL isn't a database, it's just a fancier document storage with an API on top. And that's both an oversimplification and there's some hint of truth in that. So, which one? Unstructured data is a common use case for NoSQL, but you can accomplish the storage within a SQL or a relational database. SQL databases, relational databases, can store blobs They can store JSON documents, XML documents natively in row along with their other relational data. This is a common SQL Server pattern for healthcare data like HL7 formats or credit reports. In both of those cases, they have a vast, complex schema, only a small portion of which will ever be populated for any given set for a patient or a borrower. These complex data documents often don't make sense to break out into a normalized table design with a table and a column for each possible value. NoSQL databases typically violate ACID compliance by default, especially that C for consistency, allowing for that eventual consistency that we talked about earlier. NoSQL databases are designed for sharded data, stretched over geographies between data centers. NoSQL partitioned architectures can have multi-primary or regionally primary databases by design. For example, Microsoft Azure Cosmos DB can create multi-primary partitions at any Azure data center in the world with a click of a button in a web browser. Rapid horizontal scaling with SQL solutions can be much more complex than with NoSQL solutions. Let's talk about vertical versus horizontal. Vertical scaling means having a bigger, badder, faster server with more CPU, more memory. Monolithic approach. And that's actually pretty simple to architect around. Horizontal scaling means having more servers hosting the same data. They can be distributed across various data centers on various continents even. This is more complex. But lots of NoSQL database platforms are designed for this. They have transaction coordinators and bidirectional synchronization built in, making it easy for developers. So, quick story here about the evolution of some NoSQL database platforms. And what I'm driving at is that maybe there's room for both. SQL is evil. Remove SQL. Be free to create amazing new data stores. And then 10 years later, this data is kind of impossible to use and report on, integrate with my other systems. Can you improve that? Of course, by adding a SQL abstraction layer. So to search, analyze, calculate, aggregate across ranges of rows in a NoSQL platform, it often must be extracted from documents or whatever it's stored in and then transformed, even if this is done behind the scenes for you. Don't decide to use a NoSQL platform just because of your desired write functionality. You need to consider your eventual analytical read functionality, the retrieving of that data, as well as integration with other databases. NoSQL solutions often must be packaged with a separate product for analytical or aggregate reporting consumption, or just simple business intelligence. For example, MongoDB, a very popular NoSQL database, they have a product called the Enterprise BI Connector, which serves up data for business intelligence via a MySQL database, a relational SQL database. So they had to build a SQL solution into their NoSQL platform just to provide reports. So don't ever do something because it sounds more open source or agile. It's more of an ideology than a technology discussion. And don't shy away from things like data types, foreign keys, constraints. I know JavaScript doesn't have data types, but they're actually kind of great. That stuff isn't so bad. And this last one is key. NoSQL doesn't necessarily make feature growth or data expansion easier. That's actually already difficult to imagine with any platform if you don't know what your data looks like yet. So in reality, in your future environment, there could be good cases for both SQL and NoSQL platforms that properly use the strengths of each. Many large platforms will feature both a relational database for transactional data and a NoSQL database, especially an in-memory or a cached database, for responding to search requests. I worked with a large Southern bank with a SQL Server as its backend core processing for financial transactions, but then a vendor-supplied MongoDB for its website usage analytics. The website reddit.com uses both Postgres, SQL Server, a SQL relational database, and Cassandra, a NoSQL database platform for different features of the website. Facebook was initially designed with both a MySQL relational database backend as well as a memcached front end to serve up quick web results. In a recent survey, 58% of companies were already using both SQL and NoSQL in their enterprise for big data side by side. As platforms vie to serve modern demands for the strengths of both SQL and NoSQL, understand that this decision really comes down to understanding your database's workload and your business's requirements. NoSQL will never kill SQL and vice versa. So the big relational database platforms can really provide capability to serve most existing workloads in a variety of ways. But new database platforms are emerging to meet modern planet-scale workload demands. New specialized database design patterns emerge because there is demand for them. So, for example, Azure Cosmos DB is a recent major commercial product to take this approach. A new platform underneath, providing APIs that make Cosmos DB walk and talk like leading NoSQL, key value, document, and graph database platforms, making an effort to unify various narrowly specialized NoSQL databases into a single global scale platform backed by Microsoft's global array of Azure data centers. If you were to write the next Twitter in the Microsoft tech stack, you would write it with Azure Cosmos DB. The newest emerging database platforms are seeking to merge the flexibility and integrity of SQL database with the scalability of NoSQL databases, and a new phrase, new SQL. These so-called new SQL platforms are emerging, trying to provide globally consistent databases. I'll say that again, globally consistent databases. Both Facebook and Google now operate on their own homegrown platforms, Tau and Spanner, that try to provide database consistency, safe transactional processing, and limitless horizontal scale. These new database platforms are built specifically for massive cloud clusters and require the development of sophisticated distributed transaction managers. Google's Spanner has also been made open source and is the foundation of Yugabyte DB, a new emerging NoSQL database platform that uses Spanner on top of Postgres, a relational database engine. So, in summary, database is good. Don't be scared of them. Don't scoff at that layer of work. It was being assigned the database layer in my senior software project that really helped me start understanding and appreciating the data layer. Don't shy away from that work in future team projects. Hug your database today. Hug a DBA only with permission. And remember, a flat file by any other name is still a flat file. And I'm looking at you, Jason. When in doubt, choose SQL and scale up. Relational platforms like Microsoft SQL Server and all the other platforms by all the major technology vendors provide the most features, the most versatility, the most integrity, and future integration out of the box. You can do many NoSQL patterns from within a SQL server. Monolith, schmonolith. Relational systems are actually the most versatile. Scale out geographically, horizontally, if necessary, with a NoSQL platform. Look for specific advantages, though, not just buzzwords. Test it out. Man, there are a lot of databases out there just waiting to be the boat anchor for a future startup. Consider platform capability wisely. And keep in mind, you're probably not special. Your data can probably be adapted to a platform that doesn't force you to recreate the wheel and engineer your way out of over-specialized, too narrow database platforms. Finally, the future is exciting. Please, you are the youth. If you're not optimistic about the future of databases and everything else right now, who will be? Please use your energy and your enthusiasm to better the world for everybody. Please use your powers of programming for good and use your data ethically. And please give back to the generation that follows you. even if you don't understand their music, and even if they're not your alma mater. Thank you very much for your time. I am now wide open for questions.
That was
Thank
epic.
you, Mr.
Epic. Nice. All right. Any questions, comments, concerns?
Great job. Proud of you. Any here?
Yeah.
All right.
There's a lot of echo, but go ahead. Are we shouting? Are we chatting? Or what are we doing, Bonnie?
Well, we're going to chat. If we have some people that are on Google Meet, if they want to chat out, I will read those questions aloud. And if we have anyone in the room that has any questions, y'all can speak up. This is your opportunity. The guru is in the house. Let's ask him some questions.
Hey, William, I have a question for you.
Go ahead, Gassan.
How long have you been doing this, and what advice do you give students regarding how much they should delve into databases?
All right. So I graduated 2003, and I was a software programmer. I was actually a .NET developer for a while there. Wasn't very good at it. They kept giving me all the database stuff. William, go work on this database part. You can't screw that up. Little did they know. And I became a full-blown DBA a couple of years into that kind of thing, and I've been doing consulting since the recession, really. So I guess about 13, 14 years now. But how much would you want to delve into the database? I would suggest more than you might think. A lot of the best developers that I work with, I work with Sparkhound. We got a whole bunch of .NET developers on a big team. We do custom software. I'm on a database and analytics team. I work with a bunch of analytics folks, but I work with a bunch of developers all the time. We all develop solutions. The best developers I work with in the .NET world, and even the ones in the open source world that I know, have a good understanding of how databases work. They don't treat the database as this black box to be abused by code, and they don't treat it as something that you have to engineer around. Use database features. You could create in-memory tables in database instead of developing your own complicated caching mechanism, for example. You can use database stored procedures for sure to replace a whole lot of things that Entity Framework does. I'm sure the Invokians talk to you all about this stuff, or they should anyway. But you should probably be more familiar with database features than a simple web developer might. When you are actually developing all the way down into that stack, you need to be aware of features that might help you out. Problems that SQL Server has already solved, like temporal tables or change tracking, stuff that allows you to identify what rows in a table have changed. You don't have to create some elaborate comparison mechanism in code to do that kind of thing. SQL's got that figured out for you. So when you're aware of the features that are around you in the database world, and whatever platform you're on, Microsoft or not, it makes you a better developer. You're going to waste less time trying to engineer your way or recreate the wheel when you're actually aware of what the database can do for you. So consider that. So I see a question in the chat. Should I use Postgres, MySQL, or MariaDB for an entirely open source database? What are the benefits of each, and how hard is each to set up? It's a great question, Justin. I don't know if I have enough time to answer this completely, but know that MariaDB is basically MySQL DB. MySQL got bought up by Oracle a few years ago, and so the MariaDB folks just kind of took their project and created MariaDB based off of that. PostgreSQL is really popular. It had been really popular in academic areas for a long time, and it's starting to see a lot more use. But I need a lot more information, Justin, to answer this question about which platform you would use. Because each of those databases have their own strengths. And I don't know if open source is among even the top 10 features that I would want to try out when picking a database platform for a project. I'm not sure I can speak to specific advantages of each one of those. I would look for the tools and packages surrounding those things. I would look for the features that are specific maybe to your data load. What kind of design do you anticipate of your data model? What kind of scaling do you anticipate if everything goes really well and you're growing like a weed? What kind of scaling do you think you'll need? And are other database systems most appropriate for other parts of your project? Searching is typically the biggest and first feature to kind of split away from the monolith. You have to come up with either a different design or maybe even a different platform. A lot of websites that have a lot of data to search use something that puts a cache in memory and then allows you to do super concatenations of searches. This is the Google type experience. And I think we even talked about this in some of the senior database review projects. If you're trying to look for, I think one of the projects was a book shop. And if you're trying to search for a string in that book and you want it to return whether or not that string is in the title, in the author's name, in the publisher's name, in the description of the book or the summary of the book or the genre of the book, all those things in different fields, you could do that in a SQL database. The query will run. Could you do it faster in a different structure? So maybe the transactional part of your database behind the scenes, how you accept orders, how you integrate with your shipping center, how you integrate with the thing that makes the labels and packages the books and manages the inventory for you. All that's in a SQL database, but the thing that searches for books in your vast library on your website, maybe that's served out of a different data structure. I hope that's a good idea. I consider a blog website as the primarily data that you deal with. So a blog website. I mean, I guess that's a lot. I know WordPress relies on MySQL a whole bunch, as does most of the internet. I don't think I'd have any specific recommendations away for that, other than a lot of blobs store blobs along with them, binary large objects. So like a picture is embedded in there, or a video, or something like that. You can do that in a SQL stack. Maybe there's a better solution for that kind of thing, to have that object stored in cloud storage and then just referenced in your code, as opposed to actually putting the blob in the database, which you can do, but it doesn't scale necessarily for very large objects. SQL actually has some features that maybe in a blob on a website, especially in a PaaS offering, a platform as a service offering, wouldn't allow you to do this kind of thing. But SQL has this thing called file stream, where if you actually wanted to store a video or a large book or a huge picture in the database, you can do that. And then FileStream actually handles, it's a feature of SQL Server that puts it on disk for you in NTFS. And then you can stream that picture off your hard disk, but SQL Server executable owns the object. And so you get the best of both worlds. It's owned by the database. It's tightly bound to the row of data that it's in, but it's also served out of the disk system, the NTFS system, which is much better at handling and streaming a movie or a music file or something like that, or a picture. Good questions, Justin. Nick says, what are your thoughts on ORMs, like Entity Framework? So I made a jab at Entity Framework earlier because if you are a developer using Entity Framework and you abuse your powers and don't use them for good, you can have Entity Framework make a lot of really ugly SQL statements. I have seen queries generated by Entity Framework that are literally 10 Word document pages long. The query itself was 10 megabytes, which means that the application had to transmit 10 megabytes of data back to the SQL Server just to begin the query. And that's something that you can do with EF out of the box. From what I understand, the latest versions of EF have gotten better about this. There have been enough complaints from beleaguered DBAs where they're starting to do some things. But even internally, one of the rules of thumb with Entity Framework and any object relational model manager is to put it in a stored procedure if the query gets too big and hairy. If you are bringing together 5, 6, 7 different entities in a huge chain, and you're not building those chains right, you're going to end up with these massive select stars joined to each other and then filtered at the end. Whereas if you were to just write that same query using your SQL skills as opposed to your .NET or your ORM skills. If you were to just write that same query in a stored procedure, it returns in a snap. That's one of the advantages of being a database savvy developer, is when you understand how the SQL engine works and how passing in these huge queries is coming from EF, coming from a machine built query, is much less efficient than just actually writing it yourself. That's one thing machines haven't exactly done better than we have yet. Overall, I don't have anything against ORMs. I've worked in companies that made their own ORM back before Entity Framework was a thing, and they're still maintaining it. They all have the same kind of advantages and the same kind of problems around the data layer. Good question, Nick. So I would encourage you to use Entity Framework. All the developers that I work with do. Just be nice to my database, please. Ismail says, what databases are most commonly used when dealing with the development of video games or those sorts of projects? That's a great idea. And I don't have a great finger on the pulse of what video games use. I know a lot of games engines themselves, like the data that stores the single player campaign that the video game is running on your computer, not connected to the internet in any kind of way, will use some sort of lightweight relational database, like a SQLite, or maybe even something